In this video, we're going to be looking at addition and subtraction of whole numbers, which will begin chapter 3, which deals with whole numbers and their operations. Now, in this particular section, we're going to be looking at addition of whole numbers and also whole number addition properties, mastering basic addition facts, subtraction of whole numbers, properties of subtraction, and introductory algebra using whole number addition and subtraction. Okay, now let's look at this particular situation here. With addition of whole numbers, there are some models that can be used. One of them is the set model. And in this situation, we have this. Suppose Jane has 4 blocks in one pile and 3 in another. If she combines the two groups, how many objects there are there in the combined group? Alright, in this situation here we have, in set A, there are 4 blocks, A, B, C, and D. So the number of elements in set A is 4. And in set B, we have E, F, G. So if you count those up, there are 3. So the number of elements in set B is 3. Okay, now in this case, notice that the sets are disjoint. In other words, those sets have no elements in common. Okay, so here the number of elements in A plus the number of elements in B will be simply 4 plus 3 or 7, which is another way of saying that the number of elements in the union of A and B. Now it's important that the sets have to be disjoint, meaning that the no elements are in common. That means if I have A here, I can't have A here. Or if I have G here, I can't have a G in set A. Otherwise, we will be drawing an incorrect conclusion. All right, now, the definition of addition of whole numbers is this. You're going to let A and B be 2 disjoint finite sets. If the number of elements in A is equal to little a and the number of elements in set B is equal to small b, then A plus B will be the number of elements in the union of A and B. Okay, of course the union means we're putting the two together, and this is the symbol for the union of A and B. And again, both A and B must be 2 disjoint finite sets. Another model for addition would be the number line model. Take a look at these two situations here. Josh has 4 feet of red ribbon and 3 feet of white ribbon. How many feet of ribbon does he have altogether? Or another situation would be one day, Gail drank 4 ounces of orange juice in the morning and 3 ounces at lunchtime. If she drank no other orange juice that day, how many ounces of orange juice did she drink for the entire day? Now, in both situations, we're adding the 4. We're starting with 0, and then we're going to go over 4 places to the right on the number line. And then we're going to go over 3 more places to the right on the number line, because we're adding 3 to that. So that will give us, we'll end up at 7. So the distance from 0 up to 7, that represents the sum of 4 plus 3, which is, in this case, 7. Students need to understand that the sum represented by any 2 direct arrows can be found by placing the endpoint of the first directed arrow at 0 and then joining it to the directed arrow for the second number with no gaps or overlaps. That means that the sum can then be read. So we talked about that 4 plus 3 is equal to 7. You start at 0, then you go over to 4, and then another directional arrow will start at 4 and go over to 7, because you're going to count 3 more places to the right of 4. You'll end up at 7. And as you can see, there are no gaps or overlaps. Okay, children can compare and order whole numbers at least to 100 to develop an understanding of and solve problems involving the relative sizes of these numbers. They think of whole numbers between 10 and 100 in terms of groups of tens and ones, especially recognizing the numbers 11 to 19 as one group of 10 and a particular number of ones. They understand the sequential order of the counting numbers and their relative magnitudes and represent numbers on a number line. Okay, let's look at another definition, which is less than. For any whole numbers A and B, A is less than B, which is written like this, A with the less than symbol, and then B. And that's if and only if there exists a natural number called K, such that A plus the quantity K is going to be equal to B. Okay, and there are some other symbols that we have here. This symbol right here is less than or equal to. So if you have A is less than or equal to B, that means that A is less than B or A is equal to B, one or the other. And A is greater than B. Now notice that the symbol is pointing to the right. And also you can think of this, that the inequality symbol always points to the smaller of the two numbers. So in this case, B is smaller than A, so we're saying that A is greater than B. That's the same as saying B is less than A. So as you can see here, the inequality symbol always points to the smaller of the two numbers. Okay, let's look at some whole number addition properties. One of them is the closure property of addition of whole numbers. Let's say if A and B are whole numbers, then A plus B is a whole number. And what the closure property implies, that the sum of two whole numbers exists and that the sum is a unique whole number. In other words, if we have 5 plus 2, you're going to get 7. And that's a unique whole number because 5 plus 2 can only equal to 7. All right, next is the commutative property of addition of whole numbers. If you have A and B, and they're any whole numbers, then the sum of A and B is the same as the sum of B and A. So A plus B is the same as B plus A. If we take the sum of 3 plus 5 in this particular situation here, we're going to get the same sum as if we added 5 plus 3. So 3 plus 5 and 5 plus 3 will give you the same answer of 8. Next is the associative property of addition of whole numbers. If you have A, B, and C, they're any whole numbers, then A plus B in parentheses plus C is equal to A plus in parentheses B plus C. In other words, I can first add A and B first, and then whatever that quantity is, I'll add that to C. That's the same as adding the sum of B and C together to A. Okay. So in other words, the grouping of the two other numbers does not matter when you're dealing with the associative property of addition of whole numbers. Whereas with the commutative property, the order does not matter. Okay. With associative, the grouping does not matter. The identity property of addition of whole numbers is this. There is a unique whole number called 0, which is called the additive identity, such that for any whole number called A, you add that whole number to 0, you're going to get the whole number back. A plus 0 is equal to A, or 0 plus A will also give you A. Like 7 plus 0 is still going to be 7. Okay, so 0 is called the additive identity. And let's look at some examples here. Which properties are illustrated in each of the following? Like in this case here, 5 plus 7 is equal to 7 plus 5. As you can see here, the order does not matter. So we have the commutative property of addition. 5 plus 7 will give me the same answer as 7 plus 5. Part B, 1001 plus 733 is a unique whole number. That's the closure property of addition. Okay, because I'm going to get a unique whole number when I add 1001 to 733, which is 1734. That's a unique whole number. Okay, another example. In the parentheses, you have 3 plus 5, and then plus 7 is equal to 5 plus 3, in parentheses, plus 7. What property would this be? Now, you want to be very careful here because this right here, the order is different. In 3 plus 5, and on the right side, you got 5 plus 3. That's the commutative property of addition. People may think that this will be the associative property because they see the parentheses here. That's not necessarily the case here. You have to look very carefully at this right here, 3 plus 5 and 5 plus 3. The order is different inside the parentheses, so it's the commutative property of addition. And part D, in parentheses 8 plus 5 and then plus 2 is equal to 2 plus, and in parentheses 8 plus 5, that's also equal to 2 plus 8 in parentheses plus 5. There are two properties that are used. First, you see the commutative property. 8 plus 5 and the plus 2 are switched to 2 plus in parentheses 8 plus 5. And then later, we did the grouping of 2 plus 8. And then add 5 to it. So you have the commutative and the associative properties used in this example. Okay, let's look at mastering basic addition facts. Okay, there are some methods of doing some addition facts. One of them is the counting on method. What that means is you start with the greater addend and then count to a smaller addend. For example, 4 plus 2, we start with 4 and then count on another 2. Like in this case, 5 and then 6. So 4 plus 2 will be 6. The second method is doubles. After student masters doubles, such as 3 plus 3, doubles plus 1, and doubles plus 2 can be learned easily. Let's say if the student knows 6 plus 6, which is equal to 12, then they can do 6 plus 7 using doubles. As 6 plus 6, that's going to be 12, and then you have to add 1 more to get 13. So 6 plus 7 will give you 13 as your answer. Also, making 10 is another method of mastering basic addition facts. You want to regroup to form a group of 10 and a leftover, like 8 plus 5. You can do this. Break up the 5 into like 2 plus 3, because you want to add 8 plus 2. That will give you 10, and then you got 3 left over, which will give you 13. Okay, now this illustration shows you 8 plus 5 in boxes here, and then they broke that up to 2 plus 3. Group that 2 with the 8 because that gives me 10, and then they got 3 left over, will be 13. Counting back is another method of mastering basic addition facts. In this case here, it's usually used when one number is 1 or 2 less than 10. For example, because 9 is 1 less than 10, then 9 plus 7 would be 1 less than 10 plus 7, or 16, because 9 is 1 less than 10. So let's use 10, add 7 to that, you get 17. But we added 1 too many, so we count back 1, that will give you 16 as your final answer. Okay, next thing we'll look at is subtraction of whole numbers. Subtraction of whole numbers can be modeled in several different ways. One of them is the takeaway model. It views subtraction as a second set of objects being taken away from the original set. And the missing addend model is an algebraic type of reasoning used where students compute a difference by determining the value of an unknown addend. Okay. Because as you can see, subtraction is going to be the opposite of addition. Because when you subtract something, you're trying to find out what number plus a given number will give you the final answer. Then you have the comparison model, where students determine how many more of one quantity exist in another. And then finally, the number line model is subtraction represented by moving left on the number line a given number of units. And we're going to look at each one of these individually. We'll first look at the takeaway model. Here you got 8 blocks in this particular circle, but here we're going to take away 3 blocks out of this particular circle. If we do that, how many blocks do we have left? In this case, we have 5. So this represents 8 minus 3, which is 5, or 5 blocks left. So that's the illustration of the takeaway model. And then the missing addend model, if we do 8 minus 3, and that's going to equal to some box. If you recall back in grade school, usually when you're doing addition and subtraction problems, they will usually give you a problem with a box there. That means you're trying to find out what number will fit in that missing box. This can be thought of as the number of blocks that must be added to 3 in order to get 8. So here the number 8 minus 3 would be like this. 3 plus what number will give me 8? In this case, it'll be 5. So 8 minus 3 is 5. And then you have the missing addend model. Well, here's just another illustration of that. You have 3 blocks, and then you want to know how many. Okay, the number of the number of elements in A is 8. So if this is 8, 3 plus what number will give me 8? And of course, it'll be 5. Let's look at the definition of subtraction of whole numbers. For any whole numbers A and B such that A is greater than or equal to B, A minus B is the unique whole number, C such that B plus C is equal to A. That's the definition of subtraction of whole numbers here, because you're trying to find out what number plus B will give me the answer of A. And that's provided that A is greater than or equal to B. And here we can use the comparison model. Here we got Juan with 8 blocks and Susan with 3 blocks. How many more blocks does Juan have than Susan? You compare those two, you can see that the difference there is only 5 blocks. That means that Juan has 5 more blocks than Susan. That represents 8 minus 3 is equal to 5. Okay, another model is the number line or the measurement model. In this case here, we're doing 5 minus 3. We start at 0, go over to 5. And then minus 3 means that we go to the left 3 places from 5. So we go 1, 2, 3 to the left, and we're going to end up at 2. So that represents 5 minus 3, which is equal to 2. Okay, let's look at some properties of subtraction. It can be shown that if A is less than B, then A minus B is not meaningful in the set of whole numbers. Therefore, subtraction is not closed on the set of whole numbers. It's not closed on the set of whole numbers here when we're dealing with subtraction. Now let's look at some introductory algebra using whole number subtraction. Sentences such as 9 plus 5 is equal to x and 12 minus y is equal to 4 can be true or false, depending upon the values of x and y. Like, for example, if x is equal to 10, then 9 plus 5 equals to x would be a false statement, because 9 plus 5 would not give us 10, it would give us 14. And if y is equal to 8, then 12 minus y is equal to 4 is true, because if you replace the y with 8, you'll have 12 minus 8, which would give you 4. So that value of y, which is equal to 8, will be true for that equation, 12 minus y is equal to 4. If the value that is used to make the equation true, it is a solution to that equation. So in this case here, y equals to 8 would be a solution to this equation, 12 minus y is equal to 4, because that value of y doesn't give us a true statement. Okay, so when you're finding solutions, you're trying to find out what values of that variable will make that equation true. And that will conclude this particular video on addition and subtraction of whole numbers.